Hi, and welcome back to question 3. We're in the November 2012 Mathematics Higher Level Paper 2 for the Namibian syllabus, and we're on question 3. Okay, so the question reads, during an experiment, the temperature T in degrees Celsius varies with time T in hours according to this formula. Now I'm just going to rewrite that. Now we have T equals 15 plus 2T minus a quarter T squared. And this is only valid from 0 to 10. Okay, so the time ranges in hours from 0 hours to 10 hours for this formula. Great, now let's get to question A. So question A says, determine an expression for the rate of change of the temperature with respect to time. Okay, so this is the temperature, that's the time. So the rate of change of the temperature is the gradient of the temperature formula. How do we find that? Well, by doing the derivative, by differentiating temperature. Okay, rate of change of temperature is the derivative or the differentiation of the temperature. Okay, so a constant just falls away, it becomes 0, and 2t will become 2, and this will be 2 times negative a quarter is negative a half, and then 2 minus 1 is 1, t to the power 1. Okay, for more information on how to differentiate, watch the previous video. Question 2 had some straightforward differentiation where I go into a little bit more detail on how to differentiate a function. Okay, so that is the derivative, and that's it. For 2 marks, what a bargain. Right, now we get to question B. Question B, and the first part says, find the interval in hours during which the temperature was dropping. Okay, so this formula, this equation should look familiar. What type of graph does this represent? Well, the coefficient of the squared variable is negative, so we have a sad face parabola. Okay, so to find where the temperature is dropping, it will be all the way to the right of the turning point. So we have to find out where is our turning point. Is the turning point between 0 and 10, or is it somewhere to the left or somewhere to the right? All of that, it'll be obvious what to do once we find the turning point. So let's find the turning point. How do we find the turning point of a function? Well, the gradient at the turning point is 0. It's a flat line. So we have to set the gradient equal to 0. That means we have to set the gradient, that's the gradient, equal to 0. And we already know what that is. So that's 2 minus a half t equal to 0. All we have to do is solve for t. So we take the negative half t over, and we make comes positive half t, and then we divide both sides by a half, so we get 4 equals t. So that's the turning point. The x value of the turning point is 4. So everywhere to the right of 4, the temperature will be dropping. And we only go up to 10, so it'll be from 4 all the way to 10, right? And at exactly 4, it won't be dropping because that's the turning point, so it'll be 0. It won't be rising or dropping, it'll be constant at that point, but then it drops all the way further. So this is our answer to question B1. Then we get to B2. So B2 says find the corresponding range of temperature in degrees Celsius. Okay, so the range of temperature from here to here, from 4 to 10. So what we do to find that is we find T of 4, and we go all the way to T of 10. Okay, so T of 4 will be when we substitute 4 into our original equation. So that'll be 15 plus 2 times t, which is 4 in this case, minus a quarter times t, which is 4, squared. Okay, let's work that out to start with. 15 plus 8, 4 squared is 16, quarter of 16 is 4, so minus 4. That gives us 15 plus 8 is 23, minus 4 is 19. So we've got 19 degrees Celsius when t is 4, so after 4 hours. Then we do t of 10, so again we just substitute 10 into the place of t. That gives us 15 plus 2 times t, which is 10 in this case, minus a quarter times t squared, and that'll be 10 squared in this case. That gives us 15, 2 times 10 is 20, 10 squared is 100, quarter of 100 is 25, so we've got minus 25. 15 plus 20 is 35, and 35 minus 25 is 10 degrees Celsius. Okay, so the range of temperatures is from 10 degrees Celsius and from 10 degrees Celsius all the way to sorry, it's temperature all the way to 19 degrees Celsius. So that's the range of temperatures. And that is our answer. If you use any other methods to find the solutions to these questions, please let me know in the comments below and we can discuss further. And I'll see you shortly for question 4.